2018, Paper 1, Sequences and Series, Question 4. The first three stages in a pattern of grey and white tiles are shown in the diagram below. Draw the next stage of the pattern, stage 4, on the diagram, and I'm sure I'll have no problems doing that. Just make sure you don't make a silly mistake with that. Based on the pattern shown, complete the table below. So you can see the number of grey tiles is actually a square. So 4 by 4 gives you 16 on the third pattern. On the fourth pattern, it's 5 by 5. I'm just saying this because it will help you a little bit later. So when I'm looking at these, aren't they all the squares of those? And if you have a square of something, it's n squared, or x squared, or z squared. Whenever you have a squared, we call that quadratic. So this is just handy to notice later. Number of white tiles stays the same. And as we look at the total tiles, just add the two of them together. And I've just put T1, T2, T3, T4, and so on going down there so that we can see clearly where we are. Moving on to part C. Assuming the pattern continues, the total number of tiles in stage n, Tn, is given by the formula. T of n is equal to n squared plus bn plus c, where b and c are natural numbers. Find the value of b and the value of c. Well, as I said, we know the total number of tiles is for t, is equal to n squared plus bn plus c. They've given us that, and that is quadratic. So imagine that was like x squared plus 2x plus 4. It's a quadratic formula. We know the answer from the table. So the table that we have over there, we already know the answers, and we're going to use the table to make two equations. Therefore, we'll have two simultaneous equations. So when I look at the first pattern, the t of 1, I can see that the t of 1 is 6. And you can also see that the t of 2 is 11. I'm not going to be using that. So the t of 1 is 6. But we know the formula, the t of n is equal to n squared plus bn plus c. So therefore, the t of 1 is equal to, sub in 1 for n, is equal to 1 squared plus b times 1 for n plus c is equal to 6. So 1 squared is 1, b by 1 is just b, plus c is equal to 6. Bring your 1 over, 6 minus 1, b plus c is equal to 5. And then we do the same thing for the t of 2. So with the t of 2, we know that the t of 2, the answer is 11. So sub in 2 into our formula. So we're going to have 2 squared plus b times 2 plus c. So we have 2 squared plus b times 2 plus c is equal to 11, because that's what the second term is. 2 2s are 4. b by 2 is 2b plus c is equal to 11. Bring your 4 over to the right-hand side. 11 minus 4. 2b plus c is equal to 7. So taking both of these equations, we now have simultaneous equations. So how are we going to solve them? Well, all we have to do is to be able to cancel out the c's. So I'm going to multiply the top line by minus 1. So top line by minus 1 gives me minus b minus c is equal to minus 5. And the bottom line stays the same. Minus c plus c is 0. 2b minus 1b is 1b. 7 minus 5 is 2, therefore b is equal to 2. I'm using this equation here to solve for c. So b plus c is equal to 5. Sub in 2 for b plus c is equal to 5. Bring your 2 over. C is equal to 3. So I know b is equal to 2 and c is equal to 3. Moving on, find the number of the stage, which has 443 tiles in total. So as you move down each of the stages, you're going to come to a tile, like one of these patterns here, and in total there's going to be 443 tiles in it, and you need to know what stage is that. So as you go down the sequence, one of the TNs will equal 443, so you need to find n. So we're going to make sure we sub b is equal to 2 and c is equal to 3 into our formula. So our formula is the t of n is equal to n squared plus bn plus c. So now it's equal to n squared plus 2n plus 3. So that is now our formula. and we want to find which tile it is. That means we are looking for n. So what do? So which Tn is equal to 443? That's what they're asking me. So my formula now is n squared plus 2n plus 3, that was b and that was c, is equal to 443. Bring your 443 over to the left-hand side. It's now minus. So we now have n squared plus 2n minus 440 when you take the plus 3 and the minus 443 together. Now I'm looking at that and I can see it's a quadratic equation. And the easiest way to solve quadratic equations is with double brackets. Now, to be honest, this one is hard. I'd find this one hard myself, but I'd probably give it a go to see if I could do it. If you're able to do it, it just saves you a little bit of time. So n plus 22 times n minus 20 will give you. So n by n is n squared. 22 by n is 22n. Then you have 22 by minus 40 gives you minus 440. And you have n by minus 20 gives you minus 20n, and that overall gives you a plus 2n. So therefore, n is equal to minus 22, or n is equal to plus 20. Now, you've got two answers here. It is not possible to have a negative n. You cannot have a term that has gone backwards. So negative n's just do not exist. Well, you cannot have a minus n, so n must equal to 20. So it's the 20th stage that has 443 tiles. Okay, if you get to this stage here and you find that hard to solve, then you use your minus b formula. So use the minus b formula to solve this also. So again, be very careful that you label them properly. A is equal to 1, B is equal to 2, and C is equal to minus 440. So there's your formula. And subbing in, oh, I forgot to put 1 in there, and we got minus 2 plus or minus the square root of 1764 all over 2. Multiply them out. Again, you get n is 20 or n is minus 22. Cannot have minus 22, so n must be 20.